Hi guys, welcome back to the another video. In this video, we're gonna start a series of data structure, but I don't want to start with the basics like array and stack. So we're gonna learn from tree. Okay. So in this video, we're gonna finish our first type of tree, the generic tree. Okay. So without wasting time, let me start this. In this video, we look how to implement and how to display all things and all the terminology related to tree. Okay, so I already prepared one diagram, some sort of diagram here. Okay, so what is called what is known as root node. So we can say, yeah, like our topmost node available in tree is called a root node. And what is leaf nodes? Like all the uh, nodes which doesn't have anything uh, like after it, so it's called leaf node. These all are act as this leaf node. And what is the child nodes for like 70? Like this is a root node, and these all are child nodes. Okay, and the most important thing, like what is the height of tree? So what these points, like here 0 and 1 I have written, this is called level of tree. If suppose we have something here, one node here, okay, and of course it will be on level 3. So now if I say what is height of my tree is, then it will be 3, because we calculate like maximum distance from root node. This we gonna calculate maximum distance from our root node. Okay, so this means as height of tree. Okay, now it's clear. Okay, now we're gonna do this implementation with the help of Java. So obviously in Java we are using object-oriented program language, so all the thing will happen with node, with the help of object, right? Sorry, not node, the help of object. So with the help of object only we create nodes. So if you look here, like right side, there is some set of code I have written here. So let me explain this why I'm using this. Okay, I have write few lines here. If you are able to see here, I take one inner class inside this class, generic class. Okay, first let me tell you the difference between generic tree and binary tree. A binary tree allow to hold only at most two nodes, at most two nodes. It means if there is a 0, 1 or 2 nodes, then it is a binary tree. Otherwise, okay, it is not a binary tree. Like in this case, it has a 3 nodes, 1 2 3. Okay, 3 links from root node, and it is not a binary tree, it's a generic tree. Okay, and if we have some sort of structure like this, then it is a binary tree. Okay, and if I say I have some structure like this, like root node and 1 2 3, this is not my binary tree. Okay, now come back to our topic, generic tree. Okay, so I told you I take this class inside our main class. Okay, so this box here, why I have taken this? Okay, look, if you carefully look to this object or node, it is a we are saying it as a node. Okay, and we are like internally, like we are implementing this as a object. How? I'm creating one class here. Okay, like name node, and I'm using one instance variable data. Why? I need some variable to hold my this data, this 7024, and I need one array list. Why? Because if you able to see here, we have some connections from our root node to this child nodes. So these all the connection I want to hold in my array list. So when someone came and say here new, I will say node, and if I say 10, okay, so it will run this set of code this much, these lines, and it will create a like object for array list, and it will initialize this data to variable. Okay, so I will use this code in my like implementation for generate tree. So like without wasting time, let me go to the Eclipse here, and I will create one package name here, generic com dot okay, generic and I will say one class here, generic class, generic tree. Okay, hope it is visible. Yeah, and I will use one class, say node, okay, integer data, and array list. Yeah, and I will say node, and here children equals to new array list. Okay, fine. Now I want to create a constructor for it, and here I will say integer data, and this dot data equals to data, and here I want to make an object like okay, I already create a object here, but I don't want to create here. I want to initialize here, so I can say okay, come here. Yeah, good, because I want to initialize this when someone want to create a node, not unnecessary. So this is a structure for my node class. Okay, for creating a one node. It finish here, and I want to create outside of this two variable, private node root, and private I will say integer size. Okay, why? If we look here, we have a root node, right, and it is available for all these children. So I create this in outer class like my root node, and size. Why? Like I want to like what is my size of this tree, how many number of nodes are there, like 1 2 3 4 5 6, total number of this whole, it is known as size. Okay, so whenever I create one object, one node, okay, I will increase this. Now I want to create a constructor for generic as well. So, and what will I do here? I will say here like first I will say I want to create one method for taking a input. So I will say take input. Okay, here, but in this I want to pass my node. I will say parent or root, whatever. Okay, but not like this. Wait, first I want to give an implementation for that. So I will say here public node and take input. Yeah, now I will say like give me the first root node, parent. Okay, and give me the child. Why I'm doing this, I will let you know, just to wait for a few minutes. Okay, and as well as okay, I will take my scanner for or taking input also. Okay, so these three things I want to pass when I want to call this method. So let me make one scanner, sc equals to new scanner system node. Yeah, good. Now I will say here like sc, and first of all, if you look here in this diagram, when I create an object for it, like when I want to create first root node, obviously my node is not pointing anywhere. Alright, I don't have any object for it. So I will say here when I want to call it first time for parent, I don't have any node, right? So I will say null, and for ith child, like I don't have any child, so I will say 0. Okay, yeah. And I want to, like when this method returns something, I want to hold this as this dot root. Not needed to add here like this or something, but I want to, okay, I will remove this. Okay, so like we can use this in term of like if we have a same we say variable here, a local variable, and it is our outside instance variable. So in this case no issue. Okay, I will pass this all three things, and now I will give implementation for here. First I will check what, like if parent equals to null, then I will give some, okay, then I will give some implementation for if block, else I will give some implementation. Okay, why I'm doing this? Suppose first time I call this method takeInput, it has null, and it will ask me, okay, like this is my root node, then I will give a implementation for root node. And suppose like I'm calling this method after creating root, then it will the different implementation for child node. And let me show you this. Okay, so don't worry about that, we will take care of all thing, and I will explain each and every single line. Okay, so I will say so enter the data for root node. Okay, in if block, else we will say so enter the data for ith child, for ith child, and in this case we will say, okay, for which child, like I want to enter the data for ith child, but for which parent, like parent data. Okay, let me tell you, wait. Here I can say, okay, for the ith child, wait, yeah, and for this ith child of, here I can use my parent dot data. Why I'm using this line, let me show you. Suppose like I already created this node, okay, and my code is executing for this 44. Then it will ask me like enter the data for ith child. For ith child means for 0th child. Okay, for 0th child of 44. Okay, and it will say me like for ith child, here 0 child of parent data 70. Okay, so that's why I have write this line here. When the code will execute, then it will give you the clear picture. Now for creating a node, I will say node data, okay, recursive as to next here, and node equals to new node, and I have to pass this data here. Fine. Now node is ready. Now our node is ready. When we are creating any node, we have to increase the size. So I increase the size here. Okay. After that I say, like, when we are creating a node, I have to increase the size. So I increase the size. After increasing the size, what I have to do now? I will say, like, how many children you want for a node. So I will ask to the user, okay, enter the children for enter the children for node dot data. It means, like, I created this, okay. Then it will ask me, like, how many children do you want for this? 70. I will say 3. Then it will execute for all this. For first this, for this, I want to make this recursive. Like, if then it come here, okay, it create this node and it will ask me, how many children do you want? I will say 2. Then it will say, okay, enter the data for this. Then it will ask, okay, how many children do you want? I say no. Then it will say, okay, now enter the data for uh, first children of 44. Now I will say 15. Then it will ask me, now enter the children for 15. I will say 0. Then it come back. Okay, let me show you that. Yeah, now I will say enter the data for that, and I will say integer children as dot next, and I will say here for integer I equals to 0 and I less than children and I plus plus, and I will say here node. Okay, let's come up, and I will say node and child equals to, I want to call this method again, take input. I will say yes, and for this I will say node. I have created node and I will say I. Good. And after this method, like, come back after executing all the tasks, then I will say for node and for children, like, array list, and add this. What add? This child. Okay, good. Now my code for making this whole tree is completed. Only one thing is remaining. I have to return this node which I have created. Okay, so I will say uh, here return node. Now fine. Now what I have to do, I have to make things visible. Like, I have to create a display. So I will say first private I will say private void, and or I will say private for displaying anything. I will say, like, because I have to create here two like method. Like, I will say private void display. Why private method here? Because I want to create one more method here. That method is also here. I want to create one public method. Public I will say void and display. I will tell you why I'm creating these two methods here, okay, with same name and different access modifier. I will say here this dot display. Call this method, and I have to give here root node. Okay, node, and you can say here I will say this dot root. Why I'm doing this? Because, as you know, my root variable here, this root variable here is private type. Got to know? That's why I don't want to be my root variable to be outside of this class. So I want, like, okay, my client will access this method public void display, but I want to use my root node inside this. Okay, so I create another method, okay, and I give root node inside it, because my root node information is not outside this class. How could like my client will pass information, right? So I create one method and I give this root node information to it, and it will give it will take care of rest of things for printing. So I will say here string str and equals to node data, okay. So and yeah, it's fine, node data, but showing me error. Change type string to integer. Okay, let me do one thing. Now you find, yeah, I will say okay. Yeah, now for integer I equals to 0 and I less than node dot size, because not this hash code, less than children, and here size, yeah, and it will goes for I plus plus, and it will say str equals to str and node sorry str plus node dot children dot get, and inside get I, okay. And when it get like index number, and for that index I want data, particular index. So this is for one particular, like when we pass something, okay. And when it want data, I will say like here str equals to str plus and. Why I'm doing and you will get to know here. And if I say sys sysO str. Now some more work to do. For integer I equals to 0, for that same method I am writing here. Now without wasting time, I should copy this and paste, okay. And but instead of doing here data, I want to call my method this dot display. Inside this, not this one, empty display, okay. And I have to say node dot children dot get I for particular node, okay. Now my display method is over, okay. Let me create one client for it. I will tell you like test, and for here I will want to make main method, and I will say here generic tree equals to new generic tree, okay. Yeah, and here I will say tree dot display. Now I have to run this program. Let's see what we gonna have. Yeah, you see, like enter the data for root node, because when we call this program, it will check here like I make here like new generic tree, okay. It came here and it check here. I call this method here, right? In this constructor it will come, I pass null here because we don't have anything right now. So the checking, so I will say okay, I want to enter 70. Now it is saying how many children you want for 70, okay. If you here how many children do you want, okay, I say okay 70. So it say like how many children, I will say 3 I want, okay. So I say I want children for 3, okay. Now it is saying enter the data for 0 children, 0 child of 70. If you look here, It is saying data for 0th child. This 44 is a 0th child, 16 is a first child, and this is a second child. Okay, so if I say okay, I will say my data is what is my data here? 44. So 44, same. How many children you want for 44? Okay, look, I say this is a recursive function. I want 44 two children, so I will say 2, and it will say 0 children, I will say 17, and how many children for 17? I will say 0. For month, what is my first? It is 15, I will say 15. For 15, 0 child. Okay, now it's a first, like first, if you are able to see a first child of 70. Okay, first child of 70. So if I say what is the first child of 70, data was first child 16. Yeah, I will say 16. And for how, like enter the child for 16, how many child? 1. Okay, then I will say 1, and it is saying okay. Now data for 0th child for 16, I will say like my what is my data? 21. I will say 21. For 21, no, nothing, 0. As same it is work for this also. I will say like third child is 24 and children is 2, and now it is saying enter data for 0, 23 and 28. So I have 23. Now for 23 I have 0, for like 88, and for this 0. Now this is a display function. Okay, look what it is showing here. 44 16. Okay, I just match something here. Let me make it proper. Just wait. What I have done wrong, why it is showing me like this? Yeah, here data I have make wrong here. I have to give one space here. Okay, so if I say here, okay, now everything is fine, at the end is come. Yeah, instead of dot I will say, yeah, now it's look good. Yeah, now I have to run this again and say run application data for, okay, let me do one thing also, little bit improvement. For node, okay, let me run this again. I will say 70, enter the children for 70 is 3, and 0th child I give one extra space. So okay, manage this. So 0th child I will say 44. How many child 44 have? 2. 2. First is 17. Okay, and no child for it. And second is 15 and no child for it. Let's come for first, this one, like it is 16. How many child? 1. Okay, and it is 21. Okay, and the child for 21, no, 0. Now at second it is come for this 24. 24 have 2 child, 23 and 88. So 23, it has 2 child. What? It has 2 child, 20. Sorry, I make it 24. Okay, let me enter here 24, like something 25 and 88. I have done just a little mistake here. It will say enter the child, I enter 88, so I have to run this again. Okay, so okay, my mistake here. Yeah, I make like this so we not make any mistake next time. Yeah. Yeah, let me run now application. for root node is my root node is 70. Yeah, the children is 3. First children is 44 and it has 2 childrens. First one is 17, it has 0 children, and second one is 15, it has 0 children. Now come for first one, it is 16, it has 1 children, and it is 21, okay, and it has 0 children. Now come for second one is 24, it has 2 children, okay, and first is 23 and it is 0. Second is 88 and it is 0. Now I will maximize it. Look, if you're able to see this, 70, it has 3 child, okay, 44, 16, 24, 44, 16, 24, okay, and for this 44 we have 2, 17 and 15. For this 17 nothing is there, for this 15 nothing is there, for 16 we have this 21, for 21 21 nothing is there, for 24 this is 23, 28, this 2, and for 23 it is, yeah. Hope now any other questions in code? Hope you get it, like why we are doing this all. So thank you guys for watching this video. That's all. In next video we will gonna look our binary tree. So thank you so much.